Kia ora and welcome to Screenlab number 3 for Compo 230. Today we're going to look at string harmonics, which are often misunderstood and misnotated, even by quite experienced composers. The first thing I'll say is that although the very idea of harmonics is common to virtually all orchestral instruments in one way or another, each individual instrument has a quite idiosyncratic way of expressing that, and this can lead to a lot of confusion for composers. For instance, some instruments, like the brass instruments, derive their entire standard playing technique from the harmonic series, meaning that players are essentially playing harmonics all the time anyway, so there's no point writing one for brass. Some instruments, such as the harp, really only have one kind of harmonic available, the octave harmonic, while other instruments have a wide range of different kinds of harmonics available. In each case, the composer and orchestrator must be aware of these and how to notate them, because they do form part of the idiomatic language of a number of instruments, particularly the strings and harp. For instance, if you look at any works by Debussy, Ravel or Stravinsky, it won't be long before you spot a string or harp harmonic. The strings have possibly the most comprehensive and complex range of harmonics available. While this can be daunting, on the plus side, if you can master string harmonics, you'll be well set up for dealing with the much simpler range of harmonics in the other orchestral instruments. So, before we dive into string harmonics, let's revise the essential information about the harmonic series. The harmonic series comes from the following fact. If we take a string, a column of air, or indeed any other flexible medium, and we place an endpoint on it, for instance by stretching it over a bridge or enclosing it in a tube, then we essentially create points on the string or in the column of air that can't move very much, while other parts on the string or column of air do move a lot. In this image, I've marked the non-moving parts in pink. In technical terms, we call them nodes, short for no displacement. I've also marked the part that moves the most in blue. This is called an antinode. Now, it helps if we visualize this in diagrammatic form. Imagine this is a string, or perhaps a column of air, or even a room. From now on, I'll only talk about strings, but bear in mind it could be any kind of enclosed or bounded flexible material. Let's say hypothetically that this particular string is the lowest string on the cello, and therefore when it's set in motion by the bow it produces a low bass C. This is certainly the most dominant pitch that we hear when a cello bows their C string, and therefore it's called the fundamental pitch. But it's not the only pitch we hear. That's because there are many other patterns of vibration that will give you two nodes at either end. For instance, take a look at this vibration pattern. It's still got two nodes at either end, but this time there are two antinodes and a new node in the middle. This particular vibration has a wavelength which is half that of the fundamental above it. Half the wavelength means twice the frequency, which means that the pitch is an octave higher. So the second harmonic is always an octave higher than the fundamental. Then there's the next vibration pattern, which, as you may have guessed, has a wavelength which is a third that of the fundamental. This means it's 3 times the frequency of the fundamental. And 3 times any frequency is a frequency an octave and a fifth higher. So the fundamental is the low C, the second harmonic is an octave higher, and the third harmonic is an octave and a fifth higher. And then there's the fourth harmonic, which is 2 octaves higher than the fundamental. There it is at the bottom. The fundamental again, the second harmonic, the third harmonic, and now the fourth harmonic, 2 octaves higher. In fact, the series of harmonics is an infinitely increasing set of frequencies, which are all whole number multiples of the fundamental. Here are the first 7. In naturally occurring sounds, the frequencies get progressively quieter as they get higher, however. Take a look at this spectrogram of a vocal sound. You'll see that the brightest harmonics, which correspond with the loudest frequencies, are at the bottom of the spectrogram. So that's the fundamental pitch and the second, third and fourth harmonic. But as we get higher up, the harmonics disappear off into inaudibility. So why does this matter? Well, it's good for us because we only have to think about usually the bottom 4 or 5 harmonics, because on strings the rest are often too difficult to hear or locate. except on the larger instruments, the cello and double bass, where you can get quite high and they are still quite audible. So for Compo 230, you're eventually going to have to learn the intervals that make up the first 16 harmonics, and here they are. For the first in-class test, you only need to focus on the first 3 harmonics, so that's pretty simple. The first harmonic is just the fundamental after all, the second harmonic is an octave higher than the fundamental, and the third harmonic is an octave and a fifth higher. There, that's simple. Of course, by the end of this course, you'll know all 16 harmonics off by heart, but for now, just focus on these 3 and count yourself lucky. Okay, so how do we produce harmonics on string instruments? Well, there are a couple of techniques, but the easiest way to remember is to go back to this conceptual diagram. So let's say you wanted to produce the second harmonic and stop the fundamental frequency from sounding altogether. So all you need to do is to create a situation where there's a new node in the middle of the string, but you can still create antinodes on either side of that node. Now you can use your finger, but if you touch the string in the middle to create the second harmonic, if you press too hard, you'll stop the vibration from moving from the right-hand side of the string where we're bowing it to the left-hand side of your finger. And while this will still create the same basic pitch of C an octave above the bottom C of the cello, you will have the full energy of the bow involved in this as a new fundamental, and therefore it will have the normal full sound of a legato stroke. With harmonics, however, the energy is dispersed further across the length of the string on both the left and the right hand side of your finger, and therefore they have a thinner, more transparent sound. Furthermore, vibrato has no effect on these natural harmonics, so there's a kind of sense of stripped back expression. Harmonics were often used in the Romantic era and early 20th century to depict something non-naturalistic, perhaps something cold or icy, or even something fantastical and fairy-like. If you go back to the full diagram of harmonics, you can now see what these coloured lines mean. It means if you lightly touch at that point on the string, you'll get that harmonic. For instance, look at the green dot at the bottom marked 1/6. If you touch the string at the 1/6 point, you'll get the 6th harmonic. And also, if you touch at the 5/6 point, you'll also get the 6th harmonic. However, if you touch at any of the other nodes there, you'll get a different harmonic, because if you touch at the 2/6 point, that is the same as 1/3, which is where the red line from the second harmonic goes. Sorry, the third harmonic. Also, if you touch at 3/6, that's halfway where the grey line goes, so you'll get the second harmonic. To make matters more complex, string players also have other more cunning ways of producing harmonics than just sticking a finger on the string. But the essential principle is always the same. You take a length of string and you lightly touch it somewhere along that length to produce a much higher pitch. Okay, so let's look now at the specific techniques for producing harmonics on strings. There are 2 main ways and they both have different pros and cons. The first method is called natural harmonics, and it's created in the way I mentioned just before. That is, you just lightly touch the open string with your finger at a particular point along the string. The second method is called artificial harmonics, and artificial harmonics involve 2 fingers, one pressing down hard and the other pressing lightly. We'll talk about the pros and cons of these 2 different techniques at the end, but we're going to now dive into these 2 techniques of producing harmonics. We will start with natural harmonics. To listen to the beautiful sound worlds of string harmonics, I thoroughly recommend listening to any of the string pieces by Italian composer Salvatore Sciarrino. His virtuosic works for strings involve numerous extended techniques, but predominantly different kinds of harmonics. Here's the first movement from his masterwork Se Capricci, which is intended as an homage to the Paganini caprices that we saw in the last Screenlab. Here's a cellist demonstrating on YouTube what happens when you run your finger lightly up and down a string.
And down near the bridge.
You can hear the harmonics jumping up and down from harmonic to harmonic.
And it's really cool on the lower strings because you have even that many more partials that are audible. So and the sound gets kind of metallic, and it's really kind of nice.
And here's a horn player doing the same thing, blowing up the harmonic series of a single tube length. So let's go back to our chart of modes of vibration. You can see that for the second harmonic there is only one place to touch, in the middle. But for the third and fourth harmonics you have two options. You can either touch at the point that's nearest the nut. This is the 1/3 or the 1/4 point along the string, depending on which harmonic you want. And there the hand is going to be in first position. Or you can touch higher up at the 2/3 or 3/4 point, and here the hand will be in a higher position. If there's a choice available, as there is with the third and fourth harmonic, then it's important that the composer instructs the performer as to which one of the touch points to choose. So, should you tell the performer to touch in the lower position or in the higher position? Well, the answer is it depends. All things being equal, the player would prefer to play in lower position, so unless you have a compelling reason for them to be up higher on the fingerboard, then the choice is straightforward. But take into account the context. If the hand was already in a higher position because of the preceding passage, then it might make sense to keep them up there. The other thing to bear in mind is that in the higher positions, the point at which they're lightly touching the string is the same as the point where they would normally play that note if it was written as a normal non-harmonic tone anyway. So in passages where, for instance, there's a rapid harmonic glissando or a fast melodic line, it might actually make more sense for the performer to touch at the same pitches as the notes they're being asked to produce anyway. Now, in this extract from my string quartet Exitus, which we've seen before, I asked Rolf to play this very high melody. Now, this would be virtually impossible for him to play in lower position for two reasons. One is that the notated pitches really would be hard to find down there in the lower position. But the other reason is that extremely high harmonics work best in higher positions anyway. And if you try to play these in lower position, they don't really work very well. For acoustic reasons that, to be honest, I don't entirely understand myself. However, if you then look later in the cello part at this little chord, here I've notated the harmonic in lower position. For a start, it's not an extremely high harmonic, it's just a double stop of a third and fourth harmonic on the second and third string. Note I've given the string indications above. And secondly, it doesn't really create a fast moving gliss or melody either, and this is another reason to keep it down in low position. So those are some of the principles as to whether you want to choose a low position or a high position for a natural harmonic. Let's now turn to the notation of each. So, notating natural harmonics. You can either use a circle above the note head, and this indicates that this is a harmonic and this is the sounding pitch of the harmonic. Or you can use a note with a diamond note head. And this means that, yes, this is a harmonic, but this is where you touch the string, and the resultant pitch may be very different from the notated pitch. Now, never ever use both together. That's just plain wrong. Now, there are some composers who will remain nameless, who clearly were not string players. They basically just used the harmonic circle on any old harmonic and left it up to the performers to find the right fingerings. This is problematic for a number of reasons. Firstly, it makes a lot of work for the performers. Secondly, it may lead to some physical problems if the composer doesn't exactly know how those harmonics are going to be realized. So the onus is on you as the composer and orchestrator to know exactly which notation you need to use in which situation and to completely understand how the string player will physically realize your harmonic. So let's move on to how you work out the correct notation. Firstly, let's deal with the high positions as they're the easiest. Basically, if you want your performer to touch the string lightly at the same pitch as the harmonic should sound, then you simply notate at the pitches you want with your harmonic circles above them. Recall that there are a number of reasons why you might want to do this. The first is that you might want the second harmonic, where the touch point is always halfway up the string, and this is where you'd normally play an octave anyway. In this example, in which the violinist is playing the second harmonic of each string from 4 up to 1, they're simply notated with the harmonic circle. The other reasons might be that you want an extreme high register harmonic, an upward moving harmonic glissando, or some other one-string harmonic melody. However, you might remember in my extract from Exitus that in fact I cheated and used diamond note head notation. Why? Well, strictly speaking, I should have used harmonic circles, but there were a number of lower position passages prior to that in the solo, and I felt it was more consistent overall if the cellist only had to deal with diamond note heads and not a mixture. Note that although you are allowed to use diamond note heads when the touch pitch and the sounding pitch are the same, if it makes the typesetting more consistent, the reverse is not true. You should never ever use harmonic circles where the touch pitch and the sounding pitch are not the same. Only use diamond note heads in this case. So let's have a look at that. On the left we have the violinist playing the third harmonic on each string. Notice the notation here. The diamond note head indicates where they should put their fingers, and a string indication is provided above each note. On the right I provided the sounding pitches of the third harmonics, which is an octave and a fifth above the open string. Note that you are not required to provide the sounding pitches on the score or parts. So in most cases you only ever need to write natural harmonics up to the fourth harmonic. Beyond there, players have difficulty in finding the harmonics, and there are also intonation issues in the higher harmonics as they vary from equal temperament tuning. This means that only a relatively small number of pitches are actually available to be produced using natural harmonics on the strings. Let's look at those pitches now. So firstly at the top, there are the open string tunings of the orchestral strings. The next row down is the second harmonic, which is easy to remember because it's just an octave above those open strings. And we can use the harmonic circle notation. Remember that double basses always sound an octave lower than written. The third row gives us the third harmonic, which is an octave and a perfect fifth above the open strings. These can either be written using the harmonic circle notation if you want them played in high position, or more usually by using the diamond touch notation, touching a perfect fifth above the open string. The perfect fifth is found at the spot exactly 1/3 of the way along the string. And then the bottom row is the fourth harmonic, which sounds 2 octaves above the open string. If you want the player to play them in high position, then again just use the circle notation, but if you want them in the more usual low position, then write a diamond-headed note, a perfect fourth above the open string. The perfect fourth is the interval located at the spot exactly 1/4 of the way along the string. So these pitches are the only pitches that are available using the natural harmonics of the orchestral strings, using their standard tuning, and only going up to the fourth harmonic. Let's listen to a wonderful example now of combining harmonics with the arpeggiando technique from the final movement of Ravel's Piano Trio in A minor. The violinist here is holding a quadruple stop hand position, lightly touching all 4 strings, while the bow oscillates up and down the strings in an arpeggiando fashion. In order from the bottom to the top, firstly they have to play a 5th harmonic on the G string, then a 3rd harmonic on the D string, then a 4th harmonic on the A string, and then a 3rd harmonic on the E string. See if you can work out the sounding pitch of that arpeggiando as an exercise in your own time. But for now, let's watch a video of this extract, and you can both see the gestural shape that it makes in the ear, as well as hearing the sparkling, glistening effect that Ravel is after. So here's that list of all the readily available natural harmonics for violin, viola, and cello, only going up to the 4th harmonic. If you'd like a copy of this list, please email me. Note that the available pitches are all white notes. There's no accidentals in there at all. This means that if you want harmonics on any of the non-white notes, then you can't use natural harmonics. But all is not lost. There is another trick to getting harmonics on any pitch you want, and that is artificial harmonics. But before we leave natural harmonics, you'll notice that for simplicity's sake on this list I've left out the double basses. However, it would be remiss of me not to mention the beautiful sound of double bass harmonics. So I'll play you an extract of what must be one of the most gorgeous passages in the orchestral repertoire that features double bass harmonics. Here is the opening of the third movement of Unsuk Chin's cello concerto. You will notice, because of the extreme high register of the harmonics as they come in, that she's written the harmonics using circle notation in high position. And just watch the double basses leaning over their instruments to gain access to the top part of their strings. In fact, their fingers are going beyond the end of the fingerboard as they reach up to find the much higher harmonics, such as the 11th harmonic, with their subtle microtonal inflections and their somewhat approximate pitches. What an amazing sound world. So if those white notes I listed before are the only ones easily accessible with natural harmonics up to the 4th harmonic, how do you get the other pitches with a harmonic sound? The answer on strings is artificial harmonics. This is an ingenious solution to the problem of only having a fixed number of pitches available. The way it works is as follows. To play an artificial harmonic, you press down normally with your first finger and touch the string lightly with your little finger a perfect fourth higher. In diagrammatic form, we can visualize it thus. The first finger, here marked in pink, creates a new end point. The little finger, marked in blue, creates a node at the quarter point, or 1/4 point. This makes a frequency which is 4 times the fundamental frequency of the stopped pitch, meaning it sounds 2 octaves higher than the stopped pitch. To notate these, you simply write a 2-note chord. The bottom note is a normal note head to indicate normal finger pressure, and the top note as a diamond note head to indicate harmonic pressure or lightly touching the string. And the artificial harmonic sounds 2 octaves above the bottom note. It's absolutely crucial, however, that the interval between the bottom and the top note make exactly a perfect fourth, not an augmented fourth or a diminished fourth. So that means you must get your accidental spelling correct. I'll just mention too that there are other stretches you can do to make an artificial harmonic, such as a 5th or a 3rd, but they're very rare and only really found in advanced contemporary repertoire, so best for this course to avoid them. Now, there are 2 great positives about artificial harmonics, and a couple of negatives. Positive number 1 is that you can create any pitch you like, as long as it's higher than 2 octaves above the lowest note on the instrument, and lower than 3 octaves above the top open string note. Positive number 2 is that you can have true glissandi. A natural harmonic glissando jumps up and down the harmonic series and doesn't have a true smooth gliss, but artificial harmonics can produce true smooth glissandi. The main negative is that the hand shape is slightly more awkward than for natural harmonics, and the timbre and intonation is also not as steady or as precise as a low position natural harmonic is. It also means they can't therefore jump around in a fast stream of notes like we heard in the Sciarrino piece at the beginning of this streamcast. Having said that, performers can practice artificial harmonics and get better and better at them. For example, here's a gorgeous rendition of an arrangement of one of Bartók's Romanian folk dances for violin and piano, in which the arranger has specified that the melody is to be played entirely in artificial harmonics, including all the little mordents and grace notes. It's an exquisite effect, and I think the young violinist here really nails the sound world and the technique of artificial harmonics. As a bonus, if you want to rewind that video, see if you can spot the moments when the violinist briefly changed from an artificial harmonic to a natural harmonic. Those were the moments when the bottom note of the artificial harmonic was written as a D, which is of course the open D string. So if we were going to summarize today's screencast, there are two main ways to achieve harmonics on string instruments. Natural harmonics are easy to play up to the fourth harmonic and can be achieved with a high degree of agility and are timbrally stable. But there's only a limited number of notes available and you can't achieve true smooth glissandi. It can also be a little confusing to work out the relationship between the touched pitch and the sounding pitch. Artificial harmonics give a much wider range of pitches and they have true smooth glissandi available and are easy to work out the sounding pitch, which is always 2 octaves above the bottom pitch. But on the downside they're a bit more awkward, less able to produce wide leaps, and are a little bit more timbrally unstable. Finally, please check out the NZSM Guide to Notation for more information about how to notate string harmonics. It will give you a lot more support in learning these quite tricky concepts. That's all for now. In the next lab, we'll finish off string techniques by looking at how string players bow their music and how you as a composer and orchestrator can correctly notate bowing in your music.